AI updates July 12, and yeah, this is a nice quote. How I use AI today is completely different from just 3 months ago. I don't remember where I saw it, it was on Twitter, but this is very true, at least for me as well. And the first, I want to talk about LLM on Snapdragon. I actually made a short video about a week ago about it. So you know that Qualcomm released their new chips called Snapdragon. There are several versions of them, and Microsoft now created a version of operating system which is Windows 11, but this is also AI, and they have a version running on Snapdragon. And you can buy them from these laptops from all major manufacturers, whether it's Lenovo, Dell, Microsoft, uh, Asus, Samsung, HP, whatever, you name it. Here is the link for good review. Am I sharing the screen? Yes, I'm sharing the screen.
Yes.
Yeah. Okay. Anyway, the interesting thing about this uh, chip that it is similar to um, Apple M1, M2, M3, like Apple Silicon series. It is system on the chip. It has CPU, it has GPU, it has NPU, which is neural processing unit, all on one chip. But memory is separate. On Apple, memory is also included. Can you please mute yourself? So they are comparable in performance with Apple Silicon computers. And what it means that they can run large language models. So you can get a laptop for about $2,000, which will have 64 gig of memory, which is unified memory. So you can run pretty big models on a small, inexpensive laptop. This is really, really a revolution. Uh, the prices are very low, so you can go from about $1,000 to $2,000, maybe a little bit more. Even without NPU, it produces 20 tokens per second, and this is on Llama 7B, which is quite impressive. This is not even with NPU. We're waiting to receive NPU support. Um, all, if not most, but maybe all of tools we're using like Llama or LM Studio, they're using Llama CPP framework, and they're working on providing this support for NPU. So maybe in a few weeks, uh, what it means is that all Windows users suddenly will be able to run models locally. Before, you needed to use Linux or Mac or some expensive server with NVIDIA, but now you will be able to run it on like a cheap, affordable, nice laptop with long battery life. So it's really a revolution. Okay, yeah, and these are the screens showing how you can run on LM Studio. This was from the end of June already, running on CPU at 20 tokens per second. So this is really good. Yagil Borovsky, he's one of co-founders of LM Studio, and he's actually here in New York, in Brooklyn. So I gave some links about him. So this is the latest crowdsourced arena leaderboard. And well, it's about the same. So on the top, we have GPT-4o and GPT-4. We have Claude 3.5, which is among the leaders. Please mute yourself. Somebody is not muted. Uh, you have Gemini from Google, again, GPT. Llama 370B still up. Gemma 227B. Uh, Gemma is a good model, but it's not good at reasoning. Um, so on the top, yeah, this is it. And then there are a lot of other models follow. Now, these are from Crowdsource Arena when you choose English. So the way it works, you go to the arena, and here you can choose category, And for example, you can choose English. Or you can use, for example, coding, which is like select which model is the best for writing code. And this is the result. And I put it here on the second page. Claude 3.5 Sonnet is the leader, even better than OpenAI GPT-4. DeepSeek Coder, GLM4. So you see a lot of choices, but Claude 3.5 is a really good model, and it's cheaper than bigger models and then OpenAI. So it's a good model to use. Now, next week we will have important anniversary. July 18th last year, Llama 2 was officially introduced by Meta, Facebook, and this started a revolution. This started an avalanche. Thousands of models were created, fine-tuned, applied, tested very, very quickly. And then in September, Mistral launched their first model, Mistral 7B, which was yet another second wave of this revolution. Uh, just for you to put it in perspective, we are all expecting Meta to release their large models, Llama 3 with 400 billion parameters, and maybe they will like release it on the anniversary. So let's see what will happen next week. How to calculate GPU memory for serving LLMs. So here is an example of 7 billion parameter models. Uh, when you have billion parameters or you have gigabyte, right? That means billion of bytes. There is a similar notions. So suppose you have model with 7 billion parameters. Then if each parameter is 32 bits, which is 4 bytes, this will be the size of the model, will be about 28 gigabytes. In reality, you need about 20% more, so you could expect the total requirement for the model to run will be like 34 gigabytes, right? But if you decrease the precision of the numbers from 32-bit to 16-bit to 8-bit or even to 4-bit, right? Then the memory requirement proportionally goes down. When we're using Llama, by default, it's using 4-bit models, and they're performing pretty good. If you go even lower to like 3 bits or 2 bits, then the models become unstable. So 4-bit, it's a good compromise. You may go to a little bit more, 5-bit or 6-bit if your memory allows. But for speed, for debugging, for testing, I find 4 bits is a good thing to use. So this is just text about it and a link which explains it. Okay, next, what is function calling in LLMs? It's actually a very simple concept. You have a request from the user, so you have a prompt, right? Then this prompt goes to large language model, and large language model ends up creating some sort of a JSON to call a real function, to call a real system, right? So function calling in LLM, you first large language model understand user request to determine which function we want to call, which action we want to use out of some list of specific actions. We identify the function, we generate structure parameters, typically in the form of JSON, and then it returns this, let's say, JSON format, which then is passed to the like regular system, not a large language model system, to run it. That's it. That's very simple. From natural language to understand what the request is, and then to actually formulate the what name of the function and the arguments to pass to it. Okay, that's it. Next is miscellaneous things. JEPA, Joint Embedding Predictive Architecture. Well, Jan LeCun repeated multiple times that regular LLMs, transformers, autoregressive models will not allow to achieve general intelligence. And he explains another architecture on which they're working, which is called JEPA. And here is a good, really good post with a lot of pictures which explains what JEPA is and how it is different from transformers. I will not go into it, just recommend you to read this article. It's really good. Uh, GitHub, write a book in seconds using Grok and Llama 3. Yeah, people saying, okay, you can ask a large language model, create me a title, a table of contents, then each chapter one by one, and then you have the book. But here, you actually have a GitHub project where you start it, you tell the system what you want to book about, and literally in seconds, you have the book completed. So here are the links, and yeah, this is yeah, this is hilarious. Generate entire books in seconds using Grok and Llama 3. Just a reminder, Grok is a specialized hardware. It's the name of the company which produces this hardware for fast inference. It may generate hundreds of tokens, sometimes even more than thousands of tokens per second. So it's really, really fast. And yeah, that's it. Uh, CELLO, Causal Evaluation of Large Vision Language Models. So CELLO is a new framework and it's a publication. So it is designed to assess causal reasoning capabilities of large language vision models. It has more than 14,000 causal questions across 4 levels of causality. Okay, so it's a good framework. It's a good data set to test reasoning of visual models. Okay, next. nsys.org RouteLLM. So LMSys, it's on Hugging Face, and the idea is that when you ask questions, for some questions you want to use a really good model, but for some questions any cheap model will do, right? So you can put a router which will select which model to route to. And this router is actually a trained large language model by itself. So this very interesting project, they created this router and you see the result, cost reduction 85% while maintaining 95% GPT-4 performance. I'm not sure who is not muted. Let me see. Sander, I will mute you. Okay, and then I close it. Next, Andrej Karpathy, Software 2.0 Computer. So Andrej Karpathy coined this several years ago, in 2017. The idea is that instead of writing code, you just tell the model what you want to happen, and the model achieves it somehow, right? To give you an idea, I want to give example of using neural networks for translation, let's say from English to French and vice versa. Before Google started using neural networks, they did translation before that, and it was about 500,000 lines of code with a lot of if-else logic. In this work, they had multiple software engineers, they had multiple linguists, like specialists in the language, knowing, let's say, English, knowing French, whatever. But then, about 12 years ago, some magic happens. They substituted this software by a very simple neural network. Well, simple by today's standard, but still, it's uniform, it's simple. The architecture is simple, but then you train it, and when it's big enough, it starts translating very effectively. So you can fire all specialists, all linguists. You don't need it anymore. If you have data like English and corresponding French and vice versa, then the system can be trained and it will perform the function by itself, right? So it is data driven. And that's what Andrej Karpathy was explaining in 2017, a new paradigm in software development where neural networks replace traditional handwritten code. Instead of writing explicit instructions, developers curate and train datasets to teach the neural networks the desired behavior. So this is, I guess, where we're all coming to, and in several years we will have no need in programmers because networks will somehow learn how to accomplish the tasks. This slide is really important and most people missed it. Frankly, I missed too, but then I came across this video. So it looks like finally AI has passed the Turing test. And it happened in May, and there is a publication at Archive. So this image explains what's happening. So when Turing test by Alan Turing was proposed in 1950, and the idea is that a human talks to a system. Well, he doesn't know who he talks to. It may be a human, another human, or it may be a computer. So you don't know who you're talking to, and then after talking for several minutes, you should say, "Yeah, I spoke to a human," or "I spoke to a computer," right? So there will be some sort of distribution, and these are distributions. This is for ELIZA, very like old system, mimicking a psychiatrist. Anyway, so this is GPT 3.5, and you see it's about 50%. This is GPT-4, and it is at 54%. So it's the first time, I guess, in history where AI mimics human, and this is for human. So still, it's not absolute, right? About 60 something percent say that this is human, and some others say that this is not human, right? But you have this distribution, and you see that AI is catching up. What's interesting is that analysis of participant strategies and reasoning suggests that stylistic and social emotional factors play a larger role in passing the Turing test than traditional notions of intelligence. So AI is already intelligent. AI can already answer your questions intelligently, but the way it structures the phrases, the reactions, kind of the way it tries to mimic emotions, maybe not very good. So it's not about intelligence anymore. It's about mimicking like cultural and emotional human behavior. It's kind of similar. Like here, there is a picture of reCAPTCHA. You know, I'm not a robot, and you press on this checkbox, and the system evaluates whether you're human or not by like how chaotic your movements are. So you need to add randomness, imperfection, to pass as a human. So I guess AI systems will become better actors and mimicking humans because they're already intelligent. So this already achieved. Okay, next. Last time I spoke about uh, mathematical multiplication free language modeling. So you know that the main complexity in transformers is matrix multiplications. And there is a way to avoid that. And how it's done by using so-called ternary numbers. These are numbers with three values, -1, 0, and 1. And somebody asked me, well, why? And why they allow to avoid multiplication? Well, they're not avoiding multiplication, but what's happening, just think what will happen if you multiply on this number. So you either multiply by 1, that means you just add, take the value as is, or you multiply by 0, that means it's just 0, or you multiply by -1, that means you change the sign. So multiplication comes to, so this is multiplication of a vector by a matrix. It comes to just addition. You take some values with 1 and some values with -1. So no real multiplication is needed, and that's how they achieve better performance, much better performance. Okay, there is some other text which I'll just skip. Next, I want to talk about TechLead. His name is Patrick Shyu, and he used to be tech lead at Google, then at Facebook. Then he was fired because, well, they didn't want him to have his YouTube channel, and he decided to keep YouTube channel. So he's a self-made millionaire. He's originally thinking. He he's strange person, but I really like him. I learned a lot from him. I don't approve everything he does, but very interesting couple of recent videos. He said that he deleted a lot of his old videos. Well, he said all his old videos with technical tutorials because nobody's interested anymore. He made a lot of tutorials over time, and people were using them. People were buying his tutorials. Now it's not happening. And imagine you are on a Titanic and trying to learn Java. So he's trying to explain like what's happening, that being productive doesn't actually give you results, at least in his experience. So he is sitting and trying very hard to be not productive and to do nothing, just stopping himself and just waiting until Bitcoin will grow to $1 million a token. It's really, well, it's his original, I don't know, sense of humor or point of view, whatever. It's kind of a satire on what's happening. He's saying that he's not sure if AI, for example, will be successful and has opportunity because a lot of regulations which are now being imposed from the government, and it may effectively kill opportunities. Well, right now we see a tremendous growth, but who knows? So what he's saying is we have studying hard, going to college, getting PhD doesn't work anymore. Advice to work hard doesn't work any longer. Attention economy instead of tech and science productivity economy. No opportunity in 9 to 5 work, so stop doing this. Stagnant economy, zero productivity. Well, I'm not really agreeing with that. Governments print money and making you poor. So whatever you do, governments can overwhelm you. Web3 and other projects were effectively shut down by regulations, fees and taxes, all kinds of fees. He considers them as scams which kill entrepreneurships. Local governments blocking external business. They're doing it to charge more, to squeeze more money from businesses. So he still believes that there is a, place for real entrepreneurs, and that you also can use the fact that there is attention economy and become a thought leader, or you can just invest in Bitcoin and wait. I really like this video by Ship channel about him. Yeah, it's a controversial figure, but I was his long-term subscriber, and I always watch his videos because he always has this not standard point of view. Okay, Numina Math, solve math problems. So a very interesting project to prove theorems. Well, this is the link on Hugging Face, and they won the first Progress Prize. Oh no, sorry, this is just solving the problem. And then there's harmonic math. This is mathematical reasoning engine, and this is actually to proving math. And you see how they lead the pack of similar math projects. Okay, Microsoft and Apple exit OpenAI board. Well, Microsoft, as you know, invested more than $10 billion in OpenAI. I think it was 12 or 13 total. And they had a seat on the board, and now they exited. And the reason why is because of regulatory scrutiny, antitrust, anti-monopoly laws. And Apple was supposed to get a seat, and now they refused it. Okay, TensorWave Cloud, very interesting. They offer AMD chips with 192 gigabytes of GPU memory. H100 from NVIDIA has only 80 gigabytes. So here you have much more on one chip. That means that you can fit a much bigger model on just one chip, which means fast execution and so on. So this is a very interesting cloud. Prompt compression and query optimization. This is a new course from Deep Learning AI, Andrew Ng. So these are really, really great courses. This is the link. So they're talking about pre and post filtering, projection, select a subset of the fields, re-ranking, move more desired results up, and prompt compression, reduce the length of the prompts. Okay, next, venture capital firm Andreessen Horowitz is planning to get up to 20,000 GPUs, including NVIDIA H100, to rent them to its portfolio companies at below market rates in exchange for equity. So GPUs are used as money. Very, very interesting. Uh, okay, fine-tuning and hallucinations. Sandra, thank you very much for sending me this. So does fine-tuning LLMs on new knowledge encourage hallucinations? Very interesting work. Learning new information during fine-tuning can cause hallucinations. So this is the main statement. In this work, authors vary the proportion of fine-tune examples that introduce new knowledge. LLMs struggle to acquire new factual knowledge through fine-tuning, as fine-tuning examples that introduce new knowledge are learned significantly slower than those consistent with the model's pre-existing knowledge. The examples with new knowledge are eventually learned, but they linearly increase the model's tendency to hallucinate. So taken together, these results highlight the risk of introducing new factual knowledge through fine-tuning and support the view that LLMs mostly acquire factual knowledge through pre-training, whereas fine-tuning teaches them to use it more efficiently. I think very important work. Thank you again. Okay. Hebia, a startup that uses Gen AI to search large documents and respond to large questions. Just got another like $130 million in Series B. Well, this is the first time I've heard of them, but successful company, work with big documents. Microsoft Minference. So this is on GitHub, and it speeds up the pre-filling of long context LLMs. So we are talking about pre-filling the matrices in the model. This approach achieves up to 10 times speed up of pre-filling of A100 while maintaining accuracy. So, well, this is about optimization of running LLMs. Facebook multi-token prediction, very important work. I think I first spoke about it in April when it was first published, but this is a new approach, but we should see more of it in the future. It's on GitHub. The reason why you get the models which are better and faster at the same time. So it's very promising. Okay, Intuit is firing effectively 10% of their workforce, which is close to 2,000 employees, and they are planning to rehire them next year, but for different purposes. This is part of their AI restructuring. Now, all accounting software, accounting systems they produce, they include AI in some shape or form. So they also have this Intuit Assist. And so the company plans to hire like back focuses of integrating AI into all its products. So they're changing the company. Shanghai Declaration on Global AI Governance. So this is big announcements. There was a leadership meeting in China, and they proposed the plan promoting AI development, maintaining AI safety, developing an AI governance system, enhancing public participation and literacy, improving quality of life through AI. Well, it's all good. The only thing is the undertone that they kind of oppose themselves to Western world and want to become leader by themselves. Okay, 11 Labs is a leader in text-to-speech, a very famous company, and a lot of new developments. And one was really impressive. It's called Voice Isolator. So it takes a speech with a lot of background voice, and on the output you have very clean recording. It's just amazing how they achieved it. And this is using AI. AMD is buying CELLO AI for $665 million. So CELLO AI specializes in the integration of AI into business solutions. So it's a big deal, and well, good. AMD is creating the new chips for AI, and now they're buying this company for business solutions. So they're making a lot of progress. Okay, tech layoffs. So we ended June, and this is statistics last year and this year. You see for the number of companies, which is blue, we have just much fewer companies. But if you compare the red ones, which is number of employees, well, it's about the same. So that's layoffs. Salaries of AI engineers were rising. So here example of salaries, Python 110, 150K a year, Rust 150, 200K a year, AI engineer 140, 250K. So these are for senior level engineers. So you see that AI engineer pays more than even Rust. Uh, AI definitely has a talent shortage, and people with good experience may get $1 million salaries. Okay, this is me unusual, and thank you.